Welcome, guys, to your flip video on the means and extremes theorem. The means and extremes theorem is just another way for saying you are going to cross multiply, but we're not supposed to use that anymore. So if we look at the word mean in math, mean always refers to the average, and I think of the mean as something that's in the middle. Whereas the extreme is something that's outside the ordinary, like extremely warm temperatures or extremely hot temperatures or extreme skiing or extreme moods or extreme anything, so it's the outside. If you think about your toes and your fingers, those are your extremes, and they get colder faster, like this little Eskimo, etc. We use the means and extremes theorem when we have a proportion. A proportion is when we have two of your favorite words, a fraction equal to another fraction, two F words. So one year on MCAS, they did ask which numbers were the extremes and which were the means. So this would be a number, this would be a number, over a number, numerator, denominator, numerator, denominator. So what helps me remember what a mean is and what an extreme is a lot of times I picture this like it's a train ride. And I've been working on the railroad all the live long day. And when I go on this train ride, I always start up here. See what that little red is? And I hear the whistle blowing. So when I first start my trip, I'm going to reach the beginning. So that is an extreme, because it's the extreme beginning of my trip. So I travel chugga 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 chugga, and I go down, and that's the middle of my trip. Therefore, it's a mean. Chugga 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 chugga. Say it with me. Chugga 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 chugga, until I reach the next stop. All aboard who's coming aboard is the mean, and in the final end of my trip, I reach an extreme. So therefore, we've got the means in the extremes. Means being in the middle of the trip, extremes being on the outside. And what this theorem really means is that when you have the means and extremes, a fraction equal to a fraction, you multiply them. Something we used to call cross multiplying. So you multiply extreme times extreme and set it equal to mean times mean. Now it's a lot more helpful when we use examples that have actual numbers in it. And so what we have right now will be a word problem including proportions. And let's say over the past 3 years, I've had 7 boyfriends. So that's 3 years, 7 boyfriends. In the next 6 years, if I continue at the same rate, how many boyfriends will I have? So this is very realistic. Let's look at this and write down the important information. And so I set up a proportion here. Notice the top of one fraction has boyfriends. So that means the top of the other fraction has to have boyfriends. And the bottom of this fraction has years, while the bottom of this fraction is years. Now, if I continue at the same rate as what the word problem said, I can figure out by using a proportion and by cross-multiplying or the means and extremes theorem. So what really happens is I'll have 7 times 6, and you can do either 7 times 6 first or 3 times f. 7 times 6 equals 3f. Now, sometimes we can skip that step, so we'll get 7 times 6, which is 42, equals 3f. Now that's a one-step equation, and I need to get rid of what number on this side? If you said the number 3, you are a superstar. Divide by 3, divide by 3. And 3 goes into 42 14 times. So that means f equals 14. And now f equals 14 what? Bananas? Artichokes? No, f equals 14 boyfriends. So lucky me, if I continue, I will have 14 boyfriends who are friends. In this next example, you go to the store You go to Five Below, and you can pay $3 for 9 headbands. And they're sexy ones. If you pay $4, how many headbands are you going to get? So, setting up a proportion, up top I've got 4 and I've got 3. So, does 4 and 3 represent headbands or money? Well, if you said money, that's correct. So, we've got money up top and money down the bottom. So, that means on the bottom of these fractions needs to be headbands and headbands. So, we set that up correctly. So, now to solve it using the means and extremes property. What I want to do is cross multiply, or means and extremes, because we're not supposed to say that, and I can do 3 times W first, or 4 times 9. 3W equals 4 times 9. You can skip this step if you'd like, where 3W equals 36. And then do I divide or do I subtract? If you said divide, you are the reason I get up in the morning. So W equals $12. Headbands, bananas, headbands. Notice how neat this is? I love these things. Now, in our next slide, it's more complicated. To develop a real-life example would be difficult, so we're just going to solve it. Notice what's different in this scenario. Here we go, yo. What is different? If you answered x plus 1, you are correct. Now, can I combine those two together? No. So what I want to do is still use the same method. But I want to put parentheses around there just to make it my life a little easier. So I'll do 3 times x plus 1 equals 4 times 9. So this needs to be multiplied using what property that begins with a D? The distributive property. So you get 3x plus 3 equals 36. So this is a 2-step. Divide by 3, minus 3. So 3x equals 33, and x is 11. So there's no unit there. And so, for your homework, it is the next slide. You're going to solve these 4 examples, and they'll be on a separate sheet, and you can open them up and note anytime. I would like to thank you for listening. And once again, good luck with your homework. Macho, macho man.